Picture this. It's 2017 holidays, and you are playing Fortnite with your friends at 3 a.m. Suddenly, you start feeling thirsty and hungry for a snack. So you silently walk to the kitchen in the darkness, open the fridge, and while drinking and eating, you ask yourself, how does a fridge work? Well, as you may already know, this is a fridge. But this one's quite overcomplicated. The truth is, a cooling system really only needs five essential components. The rest are just bonus features pretending to be important. Those five guys are the compressor, the condenser, the expansion valve, the evaporator, and the thermostat. But the real protagonist here is refrigerant liquid. Thanks to it, fridges can redirect heat and maintain your leftover chicken burrito fresh. Refrigerant liquid flows in special coils, which are called condenser or evaporator coils based on their function. To really understand how a fridge works, we need to talk about something that sounds way scarier than it actually is. Part 1. Ideal gas law. PV equals nRT. Don't panic. It just means that the pressure, volume, and temperature of a gas are all connected. If you mess with one, the others react. So, in a fridge, the refrigerant is constantly playing this game of squeeze and release between compression creating hot, high pressure gas, and expansion creating cold, low pressure gas. That's how we get heat to move from one place to another. Part 2. The circuitry. You see, a fridge is a closed circuit, so we don't have a clear starting point for our analysis. Because of it, let's leave it to luck. Okay, firstly, we have our little friend, the compressor. Think of it as the heart of the system. Its job? Take the refrigerant gas that's been chilling around at low pressure and squeeze it hard, increasing both its pressure and temperature. Basically, it's like the gas is being forced into a pair of skinny jeans, two sizes too small. Pressure goes up, and so does the heat. That's straight from the ideal gas law. When you reduce the volume, the pressure and temperature rise. That's why the compressor gets hot. It's doing high-intensity thermodynamics inside a metal box. Once the gas is all hot and pressurized, it travels through the condenser coils, the ones on the side of your fridge. Here, the refrigerant lets go of its heat, cooling down and turning back into a liquid. In other words, the fridge is basically throwing all the stolen heat into the room. That's why the side feels warm. It's not heating your kitchen on purpose, it's just getting rid of the heat it stole from your burrito. You'll understand it better later. Next, the refrigerant, now a high-pressure liquid, moves on to the expansion valve, or the capillary tube if you're into fancy names. This little device suddenly drops the liquid's pressure, and as pressure plummets, so does temperature. Again, the ideal gas law comes to the rescue. It's kind of like when you open a can of soda and it gets instantly colder. Only here it's much more controlled and useful. Now, the refrigerant enters the evaporator coils, the cold metal tubing hidden inside the fridge. Here's where the real magic of thermodynamics happens. The refrigerant starts evaporating, turning from liquid to gas, and to do that, it needs to absorb heat. And where does it get that heat from? From the air and food inside your fridge. That's how your leftovers stay cold. They're literally losing their heat to the refrigerant. Once the refrigerant has turned back into a low-pressure gas, it's sucked back into the compressor and the loop starts again. Squeeze, release, chill, repeat. It's a never-ending cycle of pressure, heat, and phase changes, a perfect loop powered by physics. Finally, watching over everything is the thermostat, the brain of the operation. It constantly checks if the fridge is cold enough. If the temperature rises, it tells the compressor to get back to work. If it's already cold enough, it lets the compressor rest. Basically, it's the fridge's manager, making sure the whole team stays in sync. Congratulations. Now you understand how a fridge works. Make sure to like and sub too. You can also comment video ideas below. See you soon.